Good morning, everyone. Hello. Welcome to the very successful PWI Northwest Technical Seminar. A fantastic turnout again. Over 200 people today. Thank you for coming. So the title of the seminar today is Innovation and Research in Rail. So we have several sponsors today who are exhibiting in the coffee room. Please make your time to speak to them. Okay. So we have award ceremony today for diplomas and all that. So it's really good that we're moving forward with corporate membership with the PWI. We have a very packed program today. So in the morning session, I'm the chair. I'm Sin Sin Su. Sorry, I forgot to introduce myself. We have 5 presentations by the industry and by universities. Okay. So we have a short presentation by Stephen Barber. He can't attend today because he is in Bangalore doing a PWI section meeting. That's wonderful, isn't it? So he's our president until 3 weeks later. I think he's being taken over by Joan Heary, who will be our next president. Okay, so let me play the video. The sound effect is not very good because there's a lot of background noise, but it's wonderful to see Stephen.
Hello to the PWI seminar in the Northwest. Many of you will know how close to my heart research and development is, and particularly the effective linking of that research and development with the real steel and concrete railway. This seminar today is going to show you how to make those links very effective so that we get the maximum value from all that research and development. The reason I'm not with you is just as exciting, and that's because I'm at the first meeting of the Indian section of the PWI at Bengaluru. Indian railways are thriving. They're growing. There's a major program of investment works in both metro and main line. The time for sharing information about infrastructure engineering couldn't be better. And the PWI couldn't be better placed to facilitate that sharing and interaction. So enjoy your seminar and look forward to the PWI growing worldwide.
Okay. Thank you, Stephen. So this is by far my favorite seminar in the country because I'm a researcher, like Stephen said. Research is in my heart, and I've been here like many times now. I believe this is the seventh session, so it's always a great turnout. I used to work in Manchester, in just a few blocks from here, John Dalton building, isn't it? Manchester Metropolitan University. I think I was there for 5 years, working with Prof. Simon Ivnitsky's team and Jan Bazan. Yes, so it's researching into vehicle dynamics simulations and all that. And before that, I was at Liverpool University for 8 years as a researcher again, in a then renowned Impact Research Center. So one of the famous projects that we had was the impact testing of the tire of the Concorde. That was in year 2000, after the crash. So it was all very exciting. So successes in innovation in the UK is not new. So this is the first one, which is the Stockton to Darlington Railway. It's the world's first operational steam passenger train in the Northeast. So can you think of any other innovations that happened in the past that is world-class? Sorry? The other one is the Liverpool-Manchester Railway, here, opened in 1830. So that was after the competition in Rainhill, the Rainhill trial in 1829. So the next one is London Underground. That's the first ever underground railway in the world. Do you know that we have the third oldest underground in the world as well? You know where it is? Yes, Glasgow. The second one is Budapest. So these are all our successes in innovation in the past. And this is a controversial one. The advanced passenger train is the world's first tilting train. And then the Italians, the French, and the Japanese, they all copied. So it was too ambitious, I believe. The project tried to introduce a lot of new stuff, innovation in the project. So apart from the active tilting, it also introduced aluminium frame and also articulated bogie. So it was too ambitious, it was too much money, and people getting ill on the train because it was tilting so much. But it was our invention. So the next one is maglev. I think very few people realize that we actually put the first maglev train on track. Have anyone traveled on that? Very good, Simon, Phil. So yes, it was connecting Birmingham International Station to Birmingham Airport. It's a slow train. It travels only like 42 kilometers per hour, but it proved the principle. And then now, Japanese are now developing a 500 kilometer per hour maglev to link Tokyo and Osaka. So the technology is there. So more recent successes, so maglev and APT are all innovations by British Rail Research. So more recently, we have the Vampire Vehicle Dynamics Modeling package, which was developed in the 70s. So it was heavily validated, and it's a very useful tool. Still, at the moment, it's the best in the world. So we have solved a lot of industry problems using Vampire Vehicle Dynamics analysis. So a few examples were back in 2007, we introduced the Javelin trains at high-speed one, and it was hunting a lot. So Mark Burstow then did a lot of simulations and understood the root cause of the problem. So it was a compatibility issue between the wheel and the rail and also the suspension. So we could use that and identify the solution for it. And then another case study was the bad bumps in the West Coast main line. Pantelino was experiencing bad bumps. We thought it was a broken rail. But then, using simulations, we realized that it doesn't like a specific feature on the track geometry. The track geometry was compliant, but it just didn't like a certain feature of the track geometry. So more recently, we have the modeling of Searchlight Lane. Mark Burstow, great work again, identified right comfort issues on an NR60H switch. So now we are trying to formulate a solution for that. Okay? So in terms of wheel-rail interface, millimeters matters. So I'm showing you a case study on how millimeters really matters to us. So this is a special switch, a French one. It was causing a lot of vibration under the train, so much so that the point machine is vibrating and failing. And the bracket was breaking as well. So the traditional method is to go in and lift and pack. So we've been doing that. I mean, the team was doing that, and it didn't work. So the team came up with a solution for that, which was to change the point motor every 3 months at, at 20 grams per shot. So that was the process and the solution for it. So meantime, this is what... So the bracket was breaking, the point machine was breaking. So the initial investigation was to instrument the bearers and the point machine to understand the behavior of the system. So you can see all the acceleration data, and then working with the manufacturers to say, maybe we can strengthen the bracket so that it doesn't vibrate so much. Is it because of natural frequency issue? You know, so using the measured acceleration, we could see that the natural frequency was 14 hertz. Maybe if we do 24 hertz or something higher, we won't have this problem. So while they're working on it, we did more further investigation, collecting more data. So this time the data was the profiles of the rails, and we found that there is a 1 mil dip in the running band. 1 mil, just 1 mil. So, so then we went and grind out, but we couldn't grind out 1 mil because it's a very delicate area. The most we could do was 0.5 mil. So that was before, and that was after. So the lesson learned is always collect the correct data, find the root cause, and apply correct solution. Okay? So the key integrity of research and development of rail is that you collect loads of data, appropriate data, to understand the behavior of the system, understand the limitations and assumptions of the analytical modeling, FE, finite element modeling. You need to know what the limitations are, and you validate the models to death, and then use a lot of scenarios, sensitivity analysis to further understand beyond the boundary that you understand, to understand even the failure modes. Using better testing facilities, that's what Huddersfield is developing and Leeds are, with representative loading condition to de-risk the implementation. So after you've done all these, and then you have controlled trials in service to identify any gaps that your modeling and testing didn't identify. So enjoy the day. We have a great lineup, so covering the system approach to research, and covering the top of rail all the way to the subgrade, and formation and subgrade, and anything in between. So have a great day. Always measure the data, understand the root cause, and apply the correct solution. That's it. Thank you.